Only Potatoes. Hello, we are Only Potatoes. Venkat, Kanush, Sahil, and Aviv. What did we build? Only Potatoes is a web platform that takes longitude and latitude to determine if an area is suitable for potato growth. This is done by looking at attributes such as temperature, humidity, soil pH, and soil moisture obtained by public APIs. Extra features. We have a heat map of where potatoes are grown. We built a Python scraper that converts prices on Amazon, priced in potatoes. We have distance to Earth to each planet and the sun in potatoes. We also have machine learning, k-means clusters. Thank you. This is our contact information.
Okay, stop sharing it. I have to share. I'll just start. You're recording? Okay. This is our web platform. This is our website. We have a pretty compact web app with our logo, a nav bar with options like heat map and distance in potatoes, price in potatoes. And we also have a main map with a bunch of dummy data. Now, if you want to add a location, say at these coordinates, you can pick a crop type. Potatoes are heavily suggested. You can submit it. And once your point is added to the map, you will know if you can grow a potato there, the temperature of that area that you want to grow a potato, the pH of the soil there, the humidity, the soil moisture, and why it's not really suited or why it is suited to grow in that area. And those are made through the API calls that we make to public APIs. And based on that, we use some kind of algorithm that determines if the vegetable is valid to grow there or not.
Yeah, so just to elaborate, basically what we've done here is we've used the Open Weather Map API and a couple of other APIs, and we're grabbing the soil moisture, the soil pH, the temperature, and the humidity. And we've taken basic average data of what potatoes usually need to grow. And through that, so we've used Python to get requests in a JSON and then convert those over to just the values that we need. And we're just comparing those using if statements to just see if they if the potatoes can grow here. And then what we're doing from there is we're getting that latitude and longitude, and if it can grow, we're adding that to the map. So that's pretty much the basic functionality of that.
So after we take on in all of these points, we run what's called the k-means clustering algorithm. This algorithm takes a bunch of points and creates clusters and basically separates them into groups to see what kind of crops like to grow in which kind of areas. So if we analyze with the k-means clustering sample collected, we can see that we have 4 main markers with one in Antarctica that is a bit hard to see. This is dummy data, so it might be a bit off since growing plants in Antarctica is a bit unheard of. But all these markers are what you call centroids, and they are centers of clusters or a main area where a certain crop grows in a cluster. So as you can see, this area has a cluster because potatoes were grown here, etc. And the same with all these other clusters. As well as having a k-means clustering algorithm, we also have what's called a heat map. Now this heat map allows us to graph the points we already have for potatoes and see how densely concentrated they are in more detail than the KNN algorithm gives us. We also have a page on distance in potatoes. So say you want to find the distance to Mercury, but in potatoes. This spot, it gives you an answer. The spot is 729 billion miles away in potatoes, or 729 billion potatoes away. So you want to input 2 random latitude and longitude coordinates. It gives you how many potatoes they are away from each other.